Hello and welcome to the Qt 6.6 webinar. My name is Adam. I'm here with my colleagues Ben and Pierre. And in this webinar, we're going to go over some of the new features available to us in Qt 6.6 and some of the feature updates associated with 6.6. We'll be fielding questions at the end of this webinar, but feel free to drop your questions in the chat in the meantime, and we'll get back to them at the end. The agenda for today in this webinar is going to cover the new feature updates and new modules introduced in 6.6, including the new Qt Graphs module, OpenType support, Qt text-to-speech updates, responsive layouts, window recording, and the QML permissions API. We'll start with Qt Graphs, which is the new module for 3D graphs. Here's an agenda for what we'll be covering with Qt Graphs, and we'll get started. So Qt Graphs is a new module in Qt 6.6, which will be the replacement module for Qt data visualization. The module will be responsible for visualizing data in 3D. This will use the Qt Quick 3D as the rendering engine to provide support for native graphics backend, and this module will no longer rely on OpenGL 2.1 like Qt data visualization does. Qt Graphs will provide the same functionality as Qt data visualization, although some functionality may not be available in technical preview. The Qt Graphs module is going to enable the visualization of data in 3D. This means it's possible to create bar, scatter, and surface graphs using Qt Graphs. Useful applications of this consist of visualizing large amounts of rapidly changing data or visualizing depth maps. You can change the appearance of your graphs in Qt Graphs by customizing them by using themes or by adding custom items and labels to the graphs. And these graphs are built on Qt 6 and Qt Quick 3D, which allows us to take advantage of things like hardware acceleration and Qt Quick. So using the Qt Graphs module is going to be pretty simple if you're coming from data visualization. The syntax is going to be the same as Qt data visualization, with the only difference being that you will, in QML at least, just import the Qt Graphs module. The syntax will be the same in both C++ and the QML APIs. So you can see with the code on the right here, we have a 3D bar graph being generated here. And the only difference from data visualization is that we are importing the Qt Graphs module rather than the data visualization model. If I flip to the other side of this example, you'll see here that we are able to create 3D bar graphs and scatter graphs and surface graphs using Qt Graphs with some various themes. The plans to have all graph-related modules. The plan is to have all graph-related modules within Qt Graphs. So in Qt 6.6, this will coexist with Qt data visualization, and in Qt 6.7, we will begin the integration of Qt charts to be able to handle 2D data visualization. The next feature is OpenType support, which will handle some new font features. A short agenda for this topic is here. And so OpenType is a font format originally developed by Adobe and Microsoft, which will allow us to use some advanced typographic features. The list of features is very extensive, but generally this is going to be used to display text in an atypical form, such as fractions, for example. A normal fraction would be displayed as this 1 and then a slash and a 2, whereas if we're using OpenType, we can see this in a more familiar format with a smaller 1/2. The list of features that can be applied to a font is going to be dependent on the font.family property, and certain fonts may not be compatible with some tags. Each of these features is going to use a unique 4-letter tag to specify the type of feature being applied. So for example, if we want to apply a fraction tag, we'll use the frac, F-R-A-C, unique 4-letter tag, or if we want to use scientific inferiors, we'll use the S-INF tag. OpenType font features can easily be applied to text in both C++ and QML. In QML, we'll use the font features property in order to apply a feature to a text component. So this property is going to take both the tag name and the value and apply that to the feature. The value in this case is going to represent a Boolean value where 0 is false and all other numbers are true. So you can see on the right here in this code, we have two text objects in QML with the font features property set, we're using the tag frac to potentially display a fraction, but the Boolean value in the first one is going to be a 0. So this should display as default, whereas the second text object is going to use the OpenType support and display this fraction in the smaller 1/2 format that we saw. So if I flip to the other side, we'll see our results. As expected, we've got this 1/2 in a normal format, and in the second text object, we have a OpenType 1/2 in the fraction form. In C++, we'll use a collection of functions added to the QFont class to handle these OpenType features, such as setFeature, unsetFeature, and feature tags.
Thanks, Adam. I'll be talking about some of the updates that come with the QTestToSpeech module. First, we have a quick agenda. We'll be having a quick overview, talk about synthesizing audio data, process control, and then finally voice selection. So starting out with a quick overview, we now have the ability to synthesize audio data from text. So applications can now call the synthesize overload. And this function will be called when new PCM data is available and allow the user to access this data for later use. We also have added some better process control with the new onQueue function, which allows for multiple utterances to be added to a queue, which will be played in succession. And then finally, we have some easier voice selection with the new find voices function. All right, starting out with synthesizing audio data. So we now have access to the synthesize overload. This will take a text input, which will be synthesized, as well as a slot, which can be called when the PCM data becomes available. And if you're not familiar, PCM is basically just a digital representation of some analog speech. So then this data can be used as needed, like being written to a file for some post-processing. So in our example here to the right, we can see we're calling the synthesize function as a lambda function, and then we're going to take the data, which is stored in this bytes variable, and write that to a file, and that will be containing the PCM data. So if I flip this over, type in the word hello, click on synthesize, and then write, we can see our file's been written successfully. And if I take a look at this file, we can see we've got our PCM data stored in a text file, as can be seen right here. All right, now talking about voice selection. So the new find voices function will allow for some easier voice selection. So prior to the implementation of this function, we would typically use the available voices function, which would return a list of all the voices that are available from our operating system. However, now we have the find voices function, which is essentially going to allow us to filter through this list and select a voice that we see as suitable for our current situation. This find voices function is going to take a list of parameters, which are going to basically define the type of voice we're looking for. So if we look at our example here on the right, we can see we're calling this find voices function, searching for a voice with a locale in the United States, a female voice, and an adult voice. So this is going to return a list of all voices within the list of available voices that match those parameters. So this should just return us a female voice, and then we can see we have a very similar function below it, which is just going to be finding a male voice. And it is worth noting that the same functionality is available in QML through the voice selector QML type. However, in this example, I am using the C++ version of this function. So now let's quickly take a look and we can see exactly how this works. So I'll just type in the word hello. And when I click say, it's going to read out a male voice.
Hello.
And so that's the male voice using the find voices function. And now let's try female.
Hello.
And there's our female voice. Again, we made these available by using the find voices function. All right, finally, we have better process control as part of the update. So some new functionalities are for improved process control, and this comes in the form of the onQueue function. So this will add the utterance to a queue to be read. So one of the problems that can be associated with the typical say function is that when we call the say function, it will actually start over every single time we repetitively call that say function. So if somebody were to kind of repeatedly click a button that is asking to read out some text, it would kind of start over the phrase being read every single time that button is clicked. This problem is solved with the onQueue function because these phrases or utterances are instead being added to a queue, which will then be read in succession. This comes with the added benefit of being able to modify the pitch, volume, and rate of that speech while it is still remained in the queue. So as long as it hasn't been begun to be read, we have the ability to modify those three values. And it is, again, worth noting that there is a QML equivalent, which is part of the text-to-speech QML type. But again, in my example here, I am simply calling this through C++. So we can see in the example, I called the onQ function through a QTestToSpeech object. And it is also worth noting that the onQ function will return the index of the current of the utterance that is in the queue. So its position in the queue will be returned, so we can keep track of which utterance is going to be read out next. And then finally, we also have added the sang word signal, which will be emitted anytime a single word is read out loud by QTestToSpeech. And this is going to allow the user to access various properties of the word being read, which we have a brief snippet of code showing kind of how we can use this here, where we actually connect up a slot called onSangWord to it, and then just print out various information about the utterance or word being read, which can be useful, again, for tracking kind of what is being read out programmatically, since the program is not necessarily able to hear the speech that's being read. So again, let's take a quick look at how this works. So I'll type in, hello, my name is Ben, and I'll quickly show or demonstrate one of the problems that can occur with the normal say function, where if I press this multiple times, you'll kind of see how it starts over the phrase.
Hello. Hello, my name is Ben.
So immediately there, we can see the problem that can come with the say function. And if I do the same thing, calling the onQ function, you'll see that it's instead going to read this phrase out in full, but 3 times in a row, or the number of times that I've actually called the function. So let's demonstrate that.
Hello, my name is Ben. Hello, my name is Ben. Hello, my name is Ben.
So there we can see kind of the difference when we add the utterance to a queue versus just calling it immediately. And again, this comes with the added benefit of being able to modify some of the parameters of the speech while it still remains in the queue. So if I do that again, I will be able to adjust the pitch rate or volume. So let's give that another try.
Hello, my name is Ben. Hello, my name is Ben. Hello, my name is Ben.
So there we saw I was able to modify the pitch of the speech while it was still in the queue. It is worth noting that if the utterance has been begun to be read, we won't be able to modify those values. They will be locked in once the speech is actually being read out. All right, so that covers the Qt text-to-speech. So now we'll be talking about responsive layouts, and in specific, the new layout item proxy type. So just a quick agenda, quick overview, and then we'll talk about using the new layout item proxy type. All right, so as I said, the Qt 6.6 has introduced an optimal way to handle responsive layouts with the layout item proxy QML type. So if you're unaware, a responsive layout is a layout that can be changed at runtime, typically based on the screen size or available space. So this can be especially useful if you're developing for a mobile device where you may want you may want the components of your application laid out in a different way based on if you are in a vertical or horizontal orientation. This was possible prior to this implementation, but the layout item proxy does make this a lot more elegant. So the layout item proxy is the new type for handling this, and it represents a target item within a layout. And it is going to take control of the target item if it is visible, and a target can be defined anywhere within the QML hierarchy. Also, positions and sizes of the target will be matching that of the layout item proxy, and the layout item proxy is going to be mimicking the target's properties as closely as is possible to be used within the layout as if it were the target itself, as it is just a proxy for that target. And then finally, multiple layout item proxies can target the same component, but only one is able to be visible at any given time, because you can't have multiple layouts being displayed at the same time, because that wouldn't make a whole lot of sense. All right, so let's take a quick look at how we can actually use this. So layout item proxy should be used in place of the actual component that is intended to be inside of the layout. And then we have the target property of the layout item proxy, which should be set to the component which should appear inside of the layout. So we can kind of see this in our example here where I have a column layout and a row layout. We can see I've created a number of layout item proxies, and I set the target to various rectangles, which are going to kind of represent the different components I could have inside of a layout. Now, each layout item proxy can have only a single target, but targets can be repeated between different instances, as we see in this example. We've got rectangles 1 and 2, both in the column layout and in the row layout, but we have a third rectangle in the column layout. So we are able to repeat those between them. However, they cannot be visible at the same time. And then target components can, again, be defined anywhere within the QML hierarchy. So they're not displayed where I define these rectangles in the example, but they could be anywhere within my QML file. They won't, of course, appear in the UI unless in the layout, which is associated, is visible. So wherever I define these rectangles, they're not going to appear inside of my UI unless the layout item proxy they are associated with is set to be visible. So yeah, the visibility of the active layout can be toggled with another layout or switch between 2 or more layouts at runtime. And this is quite simple to do. As we can see here, I have an on with changed signal handler, which is going to toggle between both of the layouts I define up here, depending on if the screen size is above or below 300 pixels. So in this, I've kind of simulated this by just creating an animation, which will reduce the size of our window and toggle between these two layouts we saw defined. So we can see I'm able to modify my layout at runtime and even add or remove components from a layout depending on where we are or depending on the available space. All right, so that's the layout item proxy. So now we can talk about some of the updates that come with Qt Multimedia and specifically window recording. So again, quick overview, and then we'll actually talk about the implementation. So Multimedia has received an update. These updates will allow the usage of window capture, and this can be very useful. It enables the ability to record a specific window. And this is going to allow for much more accurate recording, which does not risk revealing any windows unintentionally, as this can happen when recording your entire screen, as we're going to see here in a moment. This is still going to be used with the capture session, but we have a new property added to it called window capture. And this is going to enable setting a video output to a capture of a specific window. And then we've also added the window capture QML type, which is used to define the properties of the window capture session. All right, so let's look at the QML implementation. It is worth noting before I do this, there is also a C++ implementation, which I don't show here, but it is functionally equivalent. So setting up a window capture is going to be very similar to setting up a screen capture if you've ever done that. You will create an instance of the window capture QML type, set the active property of that type to either true or false, which will determine if it is currently capturing. So you can toggle between different capture methods by toggling their active properties. And then the window property determines which window is actually being captured, and we can obtain a list of all capturable windows using the capturable windows function, which is actually exactly what we're doing in this example here, where we can see I'm going to return a list of all capturable windows, and then I will select which of these windows I want to capture at runtime using a menu and a repeater. And then finally, we'll need to create a capture session QML type, which will set the window capture property to the window capture QML type. And then we can provide the capture session to a video output to actually display the captured window, which we'll take a look at right now and see what that looks like. So right now, I'm actually in a screen recording. So we can see if I go over to the screen that we are recording, we can see if I were to reduce the size of my window, we can see we're going to display my entire screen, which could be unideal if perhaps behind this screen I had something I didn't want to be recording. So instead, we now have the window capture. So we can see here we've got a list of all the windows I could capture, but I would like to take a look at a very specific one right here. So this is the same exact window. However, now we are in window capture rather than screen capture. So if I were to reduce the size of this window, we can see we're not going to reveal anything potentially sensitive. And you can see if I were to adjust my window size, we can see it adjusts accordingly in our window capture. So that is a very nice update if we are doing screen capture or window capture. All right, and that covers my part. So actually, Pierre is going to be talking about the permissions API in QML. So I'll pass it over to him.
Yes, thank you, Ben. So yes, I will be introducing you permission in QML today with a bit of overview, explain how to use permission and some best practices we recommend. This API enables developers to request the user permission to access certain machine resources, and therefore it improves machine security by only handling over potentially sensitive data to the application with the user's consent. So in Qt 6.6, what has been added is QML support. Some permission types, so some QML types, have been added to the Qt QML core module. And this module was introduced in Qt 6.5. So that means that the permissions that were already available in Qt Multimedia and Qt Location modules have also been moved to Qt QML core module. So you will have, for instance, the Bluetooth, calendar, camera, contact, location, and microphone, which are supported and have their corresponding permission type, such as Bluetooth permission, contact permission, and so on. Availability of permission is platform dependent, and not all platforms are supported. And notably, the API is not available on Windows nor Linux. So how to use a permission in QML? Actually, it's relatively straightforward. You just need to create a component for the resource you need the permission to access to. For instance, here in our snippet on the right, we are creating the microphone permission component because we want to ask a permission for the microphone. You can know the current status of a given permission with the status property and request a permission with the request method. So a typical use case is to create states and change properties of some objects in your UI based on the status of a given permission component. Besides, each permission also exposes individual properties of their associated C++ class. So for instance, local permission will have the request method and the status properties, but also the availability and accuracy properties that were already available in the location permission C++ class. And of course, you can take a look in the documentation for each permission to quickly check what are the properties you can use for this permission type. So there are two things to keep in mind when working with permissions in QML. First, the properties of permission can be changed even after a request has been initiated by calling request. Also, the permission state is tied to the underlying application, but a permission component reports its own status independently of the others. So before moving to the example, let me just give you some generic best practices when you manage application permission. So first, you should request a minimal set of permissions that you need, and you should request permission in response to a specific action by the user. So for example, when the user wants to take a picture or something like that, that's when you will request the camera permission. And when you request for a permission, you should present extra context and explanation if needed. And when you do that, please be transparent and explicit about why the permissions are needed. Also, you should account for denied permission if the permission is refused. And lastly, you should not request permission from a library, but from your application. So I will now show you an example of the permission created in QML. So I am running it in Qt WebAssembly because it's supported here. And now I am in my Google Chrome web browser, and I have started my QML application, and we can see here we have the permission for this website. And I will be asking for the location and the microphone permission. And for now, they are set to ask, so the default. So here I have a tab handler. I will click on that. And here I can ask for the microphone. I will block it. And now you can see the access has been blocked. And as I have said, I have changed my UI based on the status of this microphone permission. If I go back to settings, now my microphone is set to block. Similarly, I can ask for the location. So here, again, I click. Now I am asked if the site can know my location. I will allow it. This will change my UI. And now you can see this site can access your location. And again, if I go to settings, now it's allowed. I can reset the permission and reload my page. And now I will need to ask for the permission once again. So it's really simple to work with permissions in QML from Qt 6.6. That is all what we wanted to discuss today about the new features of Qt 6.6. Thank you for attending this meeting, and we will now take your question in the chat.